personal finance practice problem using OneNote. Annuity initial investment present value of an annuity calculation. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side. We're in the Practice Problems tab down in the 1162 Annuity Initial Investment Present Value of Annuity tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below. We're looking at an investment type of situation. You could think about this in terms of an investment for retirement type of situation, or some other scenario where you're trying to get to some point in the future and have enough money that you can pull money out on a periodic basis. So in a retirement situation, then in order to save for retirement, you first need to know how much you're going to need at retirement, and then think about in your earning years how much you're going to have to save in order to meet that goal at retirement. Once at retirement, your savings are going to be going down, most likely. They're not going to be going up anymore. You want to have enough money so that basically it can span your life expectancy, it being going down, but hopefully generating revenue as well, generating interest income or gains on the investment. So the idea then is going to be, I need to have enough money. You're imagining you're going to take a fixed amount out periodically, let's say yearly, and you want to have enough earnings within the investment that you can kind of eat into it and be okay through that retirement period. So that's one common scenario. Similar kind of scenario if you're saving for something like college, where you're expecting like a 4-year spending that's going to take place over a 4-year time period. And then once you hit that point, you're going to start to be eating away at the savings as you spend it on a yearly basis, as opposed to be saving for it. So here's the scenario. How much would we have to invest to be able to take out each year $500? So $500, we want to take that out each year. For 7 years, we have a rate of the 7%. So meaning we need this lump sum amount of money once we hit the point where we're actually removing money from the investment account on a periodic basis and still have enough money to cover the 7-year period. Once we know that, once we know the lump sum that we would need, say like this is not like a retirement type of money, but say we know what that is on a retirement type of money, or whatever goal we're looking for, then we can think about how to save to get to that lump sum that we're going to need at the point in time that we start eating into it. Okay, so if I look at this, you can first say that the total payouts that we're going to be looking at are going to be the 500 times 7. So if we simply say, okay, well, I'm going to need 500 times 7, I'm going to need $3,500 if I'm going to be taking out $500 each year for 7 years. But of course, we're going to have money in the savings account, so you don't need quite that much if whatever you have in there is generating a return, we're going to say at the 7%. So as you eat away at it, as you start taking the $500 out, it's going to be earning less and less interest because you're going to have less principal in there on which to earn interest, but it will still be earning money, hopefully, as long as you have money in the account. So we're going to say, all right, how much would we actually need? That's going to be a present value of an annuity type of calculation. And if you're looking at this problem, it's a little bit confusing to think that it would be a present value of annuity. You probably would say, hey, this is an annuity calculation because we're looking at a series of payments. Then the question would be, well, is it a present value or future value of an annuity? It's going to be the present value because what we're trying to do is present value this series of payments to see how much we would need to have at the lump sum at the beginning, so that we can then, once it's basically being eaten away at as we chunk into the $500 per period, then we would have enough to cover it. So we'll do the present value calculation, and then we'll kind of verify it down here with our running balance calculation. So the present value, if we're looking at this in an Excel worksheet, which would be probably the easiest way to do this with an Excel function, that's what you would most likely do in practice. I would do this and then prove it to myself with a running balance calculation in Excel. And then in a school setting, you might do it with a formula calculation and with the tables, which we'll do secondly. So we then have the present value, which is going to be negative present value, and then the rate, which is going to be the 7%, comma, the number of periods, which is going to be 7, comma, and then we have the payment, which we will be using because this is going to be an annuity type of calculation, and that's going to be the $500 payment amounts. That will give us then the $2,694.64 about that we would need on a present value calculation. So if we were going to eat into this amount, so we're at the point in time where we're going to be taking $500 out yearly, then we don't need the 3,700, which would be the 7 times 5, but only the 2,694.64, because everything that we have not yet taken out should hopefully still be generating a return of the 7%. Now let's kind of prove that to ourselves so we can say, okay, does that really make sense? Let's do a running balance calculation and see if I can kind of make that make sense to myself, right? So I'm going to run the calculation with 7 periods, and we're going to start then with the investment amount of the 2,695. So we're starting with the amount that we calculated to be here, and then we're going to go through our increase, which is going to be the rate of interest that we're going to be earning that on the principal that is still in the investment, and then we're going to be taking out the payments, which will be $500 over the 7 years. So if in period 1 we had the 2,695 in there, we'd have about 2,695, it's rounded, times the 0.07, that's going to give us about 189 about. Then we're going to take out 500. So we're taking out more money than the interest that is being earned is generating. Therefore, the investment amount is going to go down. And obviously, as we do this, the amount of income, interest, let's say, or whatever income we're generating from the investment will also go down as the principal goes down, but we'll still earn some income as long as we have principal in the investment. So we're going to take that, and let's do it this way. We'll take the 2,695 plus the 189 minus the 500, means then we're going to be at the 2,383 about. And then if we take that and multiply it times 0.07, we're going to then get the 167 about. We're going to take out another $500 at this point. So now we've got the 2,383 plus the 167 we're going to earn on it minus the amount that we're going to take out, which is $500, bringing us to a balance of about 2,050. We're going to take that times the 0.07. We're going to get about then the 144. We're taking out another 500. So we've got now the 2,050 plus we earned 144 minus we're going to take out another 500. And that's going to bring us down to the 16494. And then we'll do it again times, we're going to say the 0.07. That's going to be about the 119. We take out another $500. So we have the 1694 plus the 119 minus the 500 is going to give us about the 1312. Then let's take the 1312 times the 0.07. I can't remember it still. I've done it 5 times now. Can't remember the number. Notice our increase or our interest or whatever our earnings are going down this time because, again, the principal is going down this time due to us taking the $500 out, which is more than the earnings each time. And so that's going to then another 500 gone is going to bring us down to the 304. We take the, or 904 times 0.07. I remembered it this time. That's going to give us then the 63. And then we're taking out the 500. So 63 minus 500 plus the 904 we had before is going to give us then the 167. And then 467 times 0.07 is going to give us the 32 finally. And we take out another 500. And that should take us down to 0 if we take the finally the 467 plus the 33 minus the 500. And that'll kind of prove our calculation to us, hopefully. Hopefully you're convinced that it's been proven now. So now we'll do it with the formula, which is a long, tedious formula. You can plug the information into here. You could say, all right, the P present value is going to equal the payment, which is going to be the 500, times 1 minus 1 over 1 plus R, 7%, to the N, 7, divided by R, 7%. Let's plug this into a table format, practicing putting a table together in a similar fashion as we would see on like a tax return or practicing financial statements. These two major components in the outer column, any inner calculations then being in sub-calculations on the inner columns. So the payment is going to be the 500. That's going to be this item. Then we're going to say the numerator, which is going to be this whole numerator. I'm going to start with 1 here and then subtract out the other component, which is going to be another subcategorization, which is going to be this 1 over the 1 plus r to the n. And I'm just going to start with 1 here on the numerator. And then I'm going to pick up the denominator, which is 1 plus r to the n, which is going to be in the inner column. 1 plus r 7% is going to be 107 to the period of n. So let's do that in the calculator. We'll say 1 plus r, say 1 plus r, which is 0.07, is 1.07, or 107% to the power of 7. We need a calculator that can do that power work. Make sure you got the calculator you need if you're doing this in a test situation. So I'm going to use a scientific one here. We're getting scientific on it. 1.07 to the power xy gives us the caret of 7. That's going to give us the 1.60578 about. Let's go back to the normal calculator. I can only be scientific for so long. I'm not a scientist, but I try. And then we've got this amount. We can divide that out. We could say, okay, that's going to be the 1 divided by, I'm looking at this column now, 1 divided by the 1.605781 about. It's going to give us about the 0.62275. So that's going to be this component. Now we're at 1 minus that component, which is just in this column now. So we're going to say, all right, let's give us 1 minus that. 1 minus this number, 0.622750, gives us about 0.37725. And then we've got the denominator, which is just r here, the rate of 7%. So we'll say, all right, 0.37725 divided by 0.07 is going to give us about, hold on a sec, that didn't work right. Something's wrong. Let's take the 0.37725 divided by 0.07. Gives us about 5.38928. And then finally, we can multiply that times this number up top, the 500, times 500. And the long, tedious journey of a problem has ended at 2,694.64 about. So then we can do it with the tables. Straightforward table work here. You would probably only have the tables in like a school type of setting where they take away your calculator and your Excel and all this stuff. So that means we're going to be looking on, and make sure you got the right table. This is an annuity table you'd be looking for. So it's present value of an annuity. We're looking for periods, 7 periods and 7%. So 7, 7, 7, 7, lucky 7, 7. There's the 7%. And then we got 5.3893, 5.3893, 5.3893. We can just simply multiply that out, do some multiplication, which is just 500 times the 5.3893. And there we have it. Note that the table is rounded to 4 digits right here, which the actual number, as we can see in our calculation, is not rounded to 4 digits. It's slightly more than that, which could result in a rounding difference, as we can see a slight rounding difference there. Probably immaterial for decision-making in practice, but could be something that you need to be aware of in a school setting if they're trying to get you to use the tables, and they might use that difference to do so.